Hey guys, welcome to another A-Level Maths Revision video. Today we're taking a look at partial fractions. It's partly through chapter 1, pretty brief, and hopefully you shouldn't find it too difficult. Okay, so if you're only doing A-Level Maths, you don't really see too much kind of the applications of partial fractions, but if you're doing further maths, you will see later on when you're doing your further maths some of the applications we can use partial fractions for. Okay, so let's just take a look at some of the standard exam questions that you could be asked. So this first one here is a nice easy one just to get us started. So we've got minus 2x minus 5 divided by 4 plus x times 2 minus x. So I want to show that can be written in this form here. So it's a over 4 plus x plus b over 2 minus x. And a and b are just constants to be found. So how do we do partial fraction questions like this? Well, what I'm aiming to do here is get it over a common denominator. Okay, and to do that, hopefully it's not anything too tricky to spot. I just times this fraction here, so I times this one here by 2 minus x, and I times this one here by 4 plus x. Okay, so you just times it by the opposite denominator essentially. Okay, so this shouldn't be anything too difficult though. So what I'm going to get now is a lots of 2 minus x plus b lots of 4 plus x. Okay, and we say this is equal to the numerator, so this is equal to minus 2x minus 5. Okay, so that's the first step in any partial fraction question like this. This one's even easy though because we only have two fractions. Sometimes you might have three, so obviously you'd have like a and then two factors here that you times it by, for example. So just keep an eye open for that, but because it's only two fractions, nice and easy. So now what we want to do here is obtain values for a and values for b. So how do we do that? Well, essentially I just need to eliminate one of the variables here. So it's either I'm eliminating a or I'm eliminating b, and then we solve for the other variable that we didn't eliminate. So for example, if I eliminate a first, so let's just say we want to get rid of a. So how do we do that? Well, we need to pick a value for x that makes a times this equal to 0. So hopefully it's not too tricky to spot again. The value here that I'm going to pick for x is just 2. Okay, if I pick x equals 2 here, this is a bracket 2 minus 2, so that's a times 0, and anything times 0 is 0. So if we let x equal 2, the a term cancels, we get plus b lots of 4 plus 2, so we get 6b. And then don't forget this right hand side here, minus 2 times 2 is minus 4, and then minus 1 over 5 gives us minus 9. And then all you need to do is just solve for b, so a nice easy equation to solve for, minus 9 divided by 6, which we can simplify to minus 3 over 2. Okay, so that's b, and then again repeat the process, but this time we need to eliminate b. So how do I eliminate b? Again, pick an x value, and simply the x value I'm going to pick is minus 4 this time. Okay, if you let x equal minus 4, we eliminate b. So this is a bracket 2 minus minus 4, so that will be 6. So I get a 6a there. That's going to be equal, the b cancels, so it's going to be equal to minus 2 times minus 4, so that's 8. Minus 5 is 3, so 6a is equal to 3. So in that case, a is equal to 3 over 6 there, okay, which you can simplify down to a half. Okay, so writing it in the form that we want to show it as. So we write out our original expression, minus 2x minus 5 over 4 plus x times 2 minus x. So this can be equal to our expression, which is a over 4 plus x. So a is 1 over 2, so we'd write this as 1 over 2 lots of 4 plus x, okay, because a is a half, so that's how we'd write it. And then b is minus 3 over 2, so we'd write this as minus 3 over, and just like we did here, 2 lots of 2 minus x. Okay, and there we have it. So we've shown what a and b is. Okay, so like I said, nice easy one to get us started. Now let's take a look at one where it's a bit more trickier. This time we've got 3 fractions to deal with. So again, the method's the exact same, you've just got an extra basically term with each letter. So what I'm going to do first is get this over a common denominator, just like we did with the previous one. So if you notice, for the p, I've got to times that by x plus 1 and x minus 5. that's going to be p lots of x plus 1 times x minus 5. The q now, so that's going to be q times x minus 2 and x minus 5. So it's basically the denominators that aren't included with the fraction you're working with. So it's plus q lots of x minus 2, x minus 5. And then we've got plus r lots of x minus 2 and then x plus 1. Okay. And remember, this is equal to the numerator of the original expression. So we write that out, that's minus 15x plus 21. Okay. And again, all we want to do here is eliminate, well, this time now, because we've got 3 variables, we need to eliminate 2 of the variables and solve for the last one that we've not eliminated for. So, for example, if I pick x equals minus 1 now, what we're solving for then is q, because I eliminate p, because minus 1 plus 1 is 0, so that expression becomes 0. Same here, I've got an x plus 1, so if x is minus 1, that full expression is 0 as well. And then we just get left with the q term here. So, let's do that. So x equals minus 1. So if x is minus 1, we get minus 1 minus 2, so that would be minus 3, and then we're going to times that by minus 1 minus 5, minus 6 there. Okay, so minus 3 times minus 6, that's going to give me 18q. So 18q, and that's going to be equal to minus 15 times minus 1, so that's 15 plus 21, giving us 36 there. Okay, nice and easy now, just divide both sides by 18 to give us 2 for q. Okay, so that's our first value. Again, repeat the process, this time we let x equal 2. Okay, so why have I picked 2? Well, if I pick 2, we eliminate q here, 2 minus 2 is 0, and same again with the r, 2 minus 2 would give us 0 for all of this. So in that case, we're solving for p this time, so 2 plus 1 is 3, and then 2 minus 5 is minus 3, that's going to give me minus 9p, and what's that going to be equal to? It's going to be minus 15 times 2, so that's minus 30 plus 21, that'll give us minus 9 there. Okay, and then just solve for p here, so divide both sides by minus 9, and we just get 1. Okay, so we're nearly there, we've just got to repeat this one more time. So what do we need to eliminate now? So we need to solve for r this time. So to do that, I'm going to have to pick x equals 5, because we need to eliminate these two. So if I let x equal 5, I'm going to get 5 minus 2 is 3, and then 5 plus 1 is 6. So we've got 3 times 6, so that's 18r. What will this be equal to? So it's going to be minus 15 times 5 plus the 21. So just plug that into your calculator, and you get minus 54 there. And again, just solve this now. R is equal to minus 54 divided by 18, and that gives us minus 3 there. Okay, and for this one, because we only need to write, basically we're only finding the values of p, q, and r. We don't need to show basically like what we can write as. We've just done that already. We found q, we found p, and we found r there. Okay, so that's that one done. Let's take a look at the slightly trickier examples now. Like you see, we've got this repeated term. We've got this x plus 1 squared. So it makes it a little bit more trickier. Nothing, you know, insane though. So let's take a look at one of these type of questions. So, question 2 here. We've got this function g of x, and we want to show that g of x can be written like this. So we want to find the values of d, e, and f first. So, again, we need to get this over a common denominator. So that doesn't change. So we need to get this over a common denominator. So if you think about what you've got to times d by, well, I've got to times d to get this over a common denominator by 1 more x plus 1, because we need x plus 1 squared, and we also need an x minus 1, okay? So there's going to be d lots of x plus 1, because we've only got one x plus 1 in the denominator. Notice under the e here, the denominator is x plus 1 squared, so we need to times it by x plus 1, and the denominator of f here, underneath the f, is x minus 1, okay? So that's d. For e then, well, notice you've already got the x plus 1 squared, so you don't need any more x plus 1s. So what do I need left now to get it over a common denominator? We need the x minus 1. So x minus 1 there. And then finally, for f here, I've already got an x minus 1. The only thing I'm actually missing is the x plus 1 squared. Okay. And again, this is just equal to the numerator, just like we did with the previous two. So this is minus x squared minus 10x minus 5. Okay. So, we've done all the preparation work here. What I need to do now, just like we've done with the previous, is start eliminating. So, for example, if I say x is equal to 1, so if we let x equal to 1, we're actually solving for f then, because 1 minus 1 here is 0, 1 minus 1 here is 0, so we eliminate d, we eliminate e, we're just going to get this f to solve for. So what's that going to give us? 1 plus 1 is 2, we square that, which is 2 squared, so 4, we times that by f, so we get 4f. It's going to be equal now to basically plug 1 into here, okay? So if you plug 1 into here, you get minus 16. So 4f is equal to 16. So f is minus 16 divided by 4 to give us minus 4. Okay, so that's our first constant there. Again, let's eliminate one more time. So with these questions, the issue is you can only eliminate twice. The third constant we find in a different method. So if we just figure out the second constant first. So for example, if I say x is minus 1, then we're solving for e. So if x is minus 1 plus 1 will give us 0. Same over here, that would be 0. So we eliminate d, we eliminate f, we can solve for e now. So x is minus 1, we get minus 1 minus 1, so that's minus 2, so we get minus 2e is equal now to plug minus 1 into this whole expression here, and you get 4. So if minus 2e is equal to 4, then e is 4 divided by minus 2 to give us minus 2 there. Okay. So then with the first two constants, how do we now work out the final constant? So we need to work out for d now. So how do we work out d? Well, to work out d, we need to consider the x squared terms. Okay. So in our equivalent bit here, this is minus x squared, so the x squared is equal to minus 1. And I need to consider what happens now with my other two x squared terms. So I've got an x squared term over here, if you expand this out, and I've also got one over here. Okay. If you expand that, that would be x squared, so that's just one lot of x squared. So that's just 1d. Same over here, this is x squared, so I've got 1f. So the x squared terms, what we're doing now is comparing coefficients. So we've got minus 1x squared there, so minus 1 is equal to 1f, so f, and we've also got 1d here, okay, because it's just x squared, so just plus d. But we know the value of f, we've already worked this out, that's minus 4. So now we just solve a linear equation here. So minus 1 is equal to minus 4 plus d. So to solve this now, I just add 4 to both sides. Okay, so minus 1 plus 4, giving us d equals 3 there. Okay, so d is equal to 3. We've got f is minus 4 over here, and we've also got e is minus 2. Okay, so like you can see, it doesn't change too much. It's just the last constant you have to work out comparing coefficients like this. Okay, the next question that we're going to cover, you see a slightly trickier example of comparing the coefficients. This one was quite nice because everything was just equal to 1 or minus 1. But the next one will show you that sometimes that's not always the case. So this is the final question here, question 12. So we've got this function h of x. We want to show that h of x can be written in this form here. Okay. So how do we do that? Well, again, just like we've done with the previous three, get it over a common denominator. So what do I have to times d by to get it over a common denominator? Well, that's just going to be 3x minus 1 all squared. Okay. What do I have to times the e by? Well, we need another 3x minus 1, and we also need the x plus 5. And we also need another 3x minus 1. And then finally, what do we need to times the f by? Well, the only thing we need to times f by is the x plus 5. Okay, and this will all be equal to the numerator of h of x, so 21 x squared minus 13. And then at this stage here, all we do is we eliminate the first two constants and then solve for two of the constants, and then finally we just compare coefficients to work out the last constant. Because again, notice you've got this repeated root here of the 3x minus 1, so when you've got a repeated root like we've got, we have to do this method. So I can spot straight away that if I let x equal minus 5, this would be 0, that would be 0, so we eliminate e, we eliminate f, and we're solving for d. So if x is minus 5, that would be 15, 3 times, that would be minus 15 minus 1. If you square that, so it's minus 16 squared, you get 256d. All of that's equal to 0, so if we just go over to the right hand side then, 21 times minus 5 squared, so that's just going to be 21 times 25, and then subtract 13. So that gives you 512. Okay? So D is just simply 512 divided by 256. So that'll give us 2. Okay? So that was a terrible 2. It gives us 2. Okay? So a nice easy one there. The next one I can eliminate. So what value can I pick for x? Well, notice we've got this 3x minus 1 here, we've got 3x minus 1 here. So what do I need to pick x as then to eliminate both of these? Well, x just must be a third, right? 3 times a third is 1, minus 1 is 0. So if I let x equal a third, and then we can solve for f in this case. So they're both equal to 0. So f times a third plus 5, so that'll give us 16 over 3. F is equal, so put a third into x squared here, so that'll give you minus 32 over 3. You put it all in to your calculator. And now to solve for f here, I just need to do minus 32 over 3 divided by 16 over 3. Okay. So to obtain f, it's minus 32 over 3 divided by 16 over 3. Just plug this into your calculator. You get minus 2. Okay. So f is minus 2. So all we need to do now is work out e. We've got d, we've got f, we just need to work out e. But just like we did with the previous one, we can't eliminate here, so we've got to compare coefficients. So remember, we're comparing coefficients for the x squared now. So in this case, it's not minus 1 this time, it's 21. So it makes it a little bit more complicated. So what we're going to say then, if we do it over here, 21 is equal, so we need to work out what, in this case, d and e are going to be, because that's where the x squareds are. This bracket is squared, and we've got 3x times x there. Okay, so if you do 3x times 3x, because remember this is just 3x minus 1 times 3x minus 1, that'd give us 9x squared. So because that's d, lots of 9x squared, in that case that's 9d. So that's 9d. And we know we've got to work out e here. So that's 3x times x. So that gives us e lots of 3x squared. So in that case, we've got 3e there. Okay. And that's equal to 21. But don't forget, we know what d is equal to. We know d is 2. We've already worked that out. So 21 is equal to 9 times 2 plus 3e. So in that case, 3e is equal to 21 minus 18. So 3e is equal to 3. So in that case, e is just simply 1 there. Okay. And if you were to write that out, so that would give you, well, if I write it all out in full, 21x squared minus 13 over x plus 5 times 3x minus 1 all squared. Well, that's going to be equal to d over x plus 5, so d is 2. 2 over x plus 5. E is 1, so that's just 1 over 3x minus 1. And then finally, f is minus 2, so that should be a minus, sorry. So we'll change that to a minus. That would be minus 2 over 3x minus 1 all squared there. Okay, and like you can see, 5 marks for that one. But there we go, that's our final answer there. So that brings us to the end of this video. I know it's not been a massively long one, but I hope it's helped. If there's anything that's unclear, please just let me know down below. Cheers.